Now see, AC voltage applied to an inductor. Prepare the circuit as shown in the figure. AC voltage is connected to the inductor. At a particular instant, the current in the circuit, that is I at time t. Now, suppose the supply voltage, that is V equal to Vm sin omega t. Now, if current I is flowing through inductor having self-inductance L, and this current is changing, then the back EMF, that is L di by dt, in previous chapter we studied this thing. So if we apply Kirchhoff's second rule to this particular loop, then we can write V minus L di by dt, that is equal to 0. Therefore, L di by dt, that is V, and that is Vm sin omega t. So we can write di, that is Vm by L sin omega t dt. This dt is taken on this side. Now if we integrate this equation, then integration of di, that is I Vm by L as it is, then integration of sin omega t, that is minus cos omega t upon omega. So we can write I, that is equal to Vm upon omega L into minus cos omega t. But now write down the equation of current in terms of sine function. So we know this thing, minus cos omega t, that we can replace by sine omega t minus pi by 2. So here I, that we can write as Im sine omega t minus pi by 2. Now see here, Im, that is Vm by omega L. Here Vm by omega L, that is replaced by Im, that is the maximum current. This is maximum voltage. Voltage divided by omega L means voltage divided by something that is equal to current. It implies that this is something that should be the resistance. So this omega L, that is denoted by XL, and that is called inductive reactance. And inductive reactance is nothing but the resistance offered to the circuit by inductor when it is connected with AC supply. Now, here see these two equations of voltage and current. So at any time t, the phase of voltage is omega t, but at the same instant t, the phase of current, that is omega t minus pi by 2. It implies that when AC voltage is applied to inductor, the current lag behind to voltage in phase equal to pi by 2. Clear? Now, instantaneous power supplied to inductor. Power P, that is V into I. So Vm sin omega t into I, that is Im minus cos omega t. So minus Im cos omega t. I equation મૂક્યું છે અહીંયા. So now minus Vm Im. Now multiply this equation by 2 and divide by 2. So here we can write 2 sin omega t cos omega t by 2. Therefore, resultantly power P, that is minus Vm Im by 2 sin 2 omega t. This is the instantaneous power at any time t. Now average power over one complete cycle. So minus Vm Im by 2, that is constant one. But now when we take the average of this sin 2 omega t, that will be equal to 0. So in case of inductor connected to AC supply, the average power over one cycle, that will be equal to 0. Clear to all of you? So now let's prepare the voltage, current versus omega t graphs and the phasor diagrams. See, voltage is Vm sine omega t, means voltage graph, that will be the sine curve. But now for current, at time t equal to 0, Im sine minus pi by 2 sine minus pi by 2, that is minus 1. So I equal to minus Im. So your current will be this much at time t equal to 0. Now if you take omega t, that is pi by 2, then pi by 2 minus pi by 2 sine 0 0, so your current is 0. And then after it follow this sine function like this. Clear to all of you? Now phasors. So voltage phasor, at any time t, the phase is omega t. So we have to represent the vector having magnitude equal to Vm in the direction making an angle omega t with respect to x-axis. So that is the phasor of voltage. Now, if we take the projection of this one on y-axis, then we will get Vm sine omega t. That is our voltage at any instant. Now, current lag behind by voltage by pi by 2. એટલે કરંટ એ વોલ્ટેજ કરતા પાઈ બાય 2 જેટલો પાછળ ચાલે છે. તો હવે આપણે અહીંયા કરંટ નો ફેઝર વોલ્ટેજ ફેઝર થી પાઈ બાય 2 એંગલે લેગ બિહાઇન્ડ રિપ્રેઝન્ટ કરવો પડે. તો હવે આપણે અહીંયા એક વેક્ટર લીધો, which one is with length equal to Im, means magnitude is Im, and now this vector is represented at an angle pi by 2 with respect to voltage phasor, but here minus pi by 2 means lag behind. So here in fourth quadrant it is represented. Clear? Now angle made by Im with x-axis, that is omega t minus pi by 2. So this part. Now if you take the projection of this one on y-axis, you will get Im sine omega t minus pi by 2. So that is your current at any instant t. So now with the help of this phasor, you will get voltage and current at any instant. Clear to all of you? Any doubt in this one? Now current is Im sine omega t. So your voltage, that is Vm sine omega t plus pi by 2, means here we used the concept, that is this one. When inductor is connected with AC supply, the current lag behind by voltage in phase equal to pi by 2. So the same thing that you can represent like this. When the inductor is connected with AC supply, the voltage lead the current in phase by pi by 2. એટલે current voltage કરતા pi by 2 પાછળ છે એવું કહીએ, અથવા તો voltage current કરતા pi by 2 આગળ છે. સેમ વસ્તુ થઈ. એટલે એ કોન્સેપ્ટ થી આ બે ઇક્વેશન લખ્યા. તો હવે see this red curve, that is the curve of current I versus omega t. This black one, that is of voltage versus omega t. Now see here, 0 to pi by 2, during this one, voltage and current both are positive, so power P, that is V into I, positive, right? So here, then after at pi by 2, voltage and current. See, voltage is 0, current is maximum, so V into I 0, power becomes 0. Then after, current, voltage. Current is positive, voltage is negative, therefore power, that is negative. Then again at pi, it is 0. So this blue curve, that is the graph of power versus omega t. Now see here what happens. When we take value of omega t, that is pi by 2, then omega, that is 2 pi by t. So small t, that you will get capital T by 4. See, omega t 2 pi radian means one cycle is completed, that is periodic time, capital T. So when 1/4 cycle is completed, means during time interval 0 to T by 4, inductor will absorb the energy from the source. Absorb the energy from the source. Clear? And then after, see the second cycle. During T by 4 to T by 4, means T by 2 time interval, the energy stored in the inductor, that will be transferred back to the source. Again, 2T by 4 to 3T by 4, the energy is absorbed by the inductor from the source. And then after 3T by 4 to capital T time, the energy stored in the inductor, that will be transferred back to the source. Clear? So in this way, during this entire cycle, 0 to capital T time, the the magnetization of inductor and demagnetization of inductor, that continue. And due to this particular reason, the average power, that comes to 0. So we can use inductor in the circuit to control the current without loss of power. Okay. So if you want to minimize the power loss and you want to control the